What's up, my dears? You're looking good today. I am Bins, and welcome back to the Shapez BEASTMAM series, the series where we go over the first, and as of date of uploading this video, still the world's only true make-anything machine made within the Shapez Industries mod of the relaxing but compelling factory builder Shapez. If you've been following along, then you will know how obsessively and compulsively I've been naming my chapters in this series. And if that rabbit hole went a little too deep for you, then I've got some good news. Let's have a look. The previous video was Chapter 5a, Episode 1c, Section 4, about how the paint lines on the wiring layer of the flat piece factories are handled. We have said everything there is to say about that, but not only that, we said everything there is to say about the flat piece factories at all. So we can close not only the section, but, as a matter of fact, the entire episode. Today, we will start with Episode 2 of our chapter, where we will look not at the flat piece factories, but the floating piece ones. And within this new episode, I want to start off by going over some theory first. We have seen how to create floating piece signals on the wiring layer back when we were in Chapter 4 about the decoder. But now, the question is going to be, if you have a floating piece signal as your point of departure, then how can you build a factory that actually creates it? And more importantly, how does the process of producing floating shapes in Shapez Industries differ from the vanilla game? That is what we will have a look at today. Now, first of all, let's go back to vanilla. In vanilla Shapez, you can create a floating piece by adding scaffolding quadrants to your mix and use stackers to glue them to the quadrants of your actual shape. Then you stack those together, and then you run the result into a cutter. The scaffolding is removed from the equation, and the remainder is your floating piece. You can do this with any shape that has either 2, 3, or 4 layers. And the important restriction is that you must limit yourself to 2 orthogonally adjacent corners, so your piece spans either the right half of the shape, the bottom, the left, or the top half. And the technique is always provide a scaffolding quadrant for each of the actual quadrants, make sure they are all in an unused corner, make sure they're all in the same corner, and then cut the scaffolding away. But now, within the Shapez Industries mod, things change a bit. First of all, as long as you remain on the same layer, you now have the option of using a combiner for your scaffolding in the first step. And then, to cut your scaffolding away, you can also use the laser cutter. And that has implications because it lifts the restriction that you can only create floating pieces that strictly occupy 2 adjacent corners. With the laser cutter, it is possible to create floating pieces with diagonally opposing quadrants too. You just need to make sure, as before, that your scaffolding bits are in a vacant, empty corner, and then you can cut away the scaffolding and keep the floating piece. As a matter of fact, the vacant corner is the only limitation you have left. In Shapez Industries, it is possible to create floating pieces with any random positioning of quadrants. The quadrants may be in any corner, as long as you have one empty corner left for providing the scaffolding, at least one empty corner that is, then the laser cutter can do it. Now, the laser cutter is a bit of a science in its own right, because it is the first cutter type that is operated by wires. And what's very confusing, and it took me a while to wrap my head around this, is what the relationship is between the signals you connect and the corners that actually get cut out. The orientation where you put the laser cutter on its side with the input on the left and the output to the right and the bottom That is the only rotation that makes sense visually. Look at what I'm doing here. The buttons that I press are in the same corner as the quadrant, or quadrants, plural, that get cut out the shape. Okay? But if we put the laser cutter in any other orientation, then its behavior gets visually confusing very fast. In this example, if I press the top left button, then it's the top right quadrant that gets cut out of the shape. And if I press the bottom right button, then the bottom left quadrant is cut out. And the reason this happens is, as with many things in this game, because we don't have to look at the behavior in absolute terms, but in relative ones. More precisely, we have to think in terms of clockwise versus counterclockwise. As a matter of fact, let's actually draw a clock on screen. Why not? If the orientation of the laser cutter is flat and moving rightwards, then 12 o'clock is north, okay? And we will define our wiring inputs as 1:30, 4:30, 7:30, and 10:30. Respectively, these inputs are mapped to the top right, the bottom right, bottom left, and top left corners of our shape. But if we rotate the laser cutter, then we also rotate our imaginary clock, while mapping between the wiring inputs and the shape corners stay untouched. 1:30 remains the top right corner. 4:30 is still the bottom right corner. 7:30 the bottom left corner. And 10:30 the top left corner. Okay, so it definitely took me a while to get comfortable with this principle, and truth be told, I still get disoriented with it. So between you and me, I've made a bit of a habit to always put the laser cutter in its flat, rightward moving position so that the wire connections actually make sense with the corners of the shape, visually, and then I connect everything the way it's supposed to, and only then I rotate the laser cutter alongside its wiring. But don't tell anyone I told you this. Now, if you add that up to our floating piece story, I hope you can appreciate that we are adding confusion upon confusion. If we want to build a floating piece factory, then how on earth can we tell the laser cutter which corner it needs to cut out? How can we set up the wiring so that it always knows where the scaffolding goes, and then instruct the laser cutter accordingly? Well, I actually decided to pull the same trick I've pulled before. Instead of adapting the laser cutter, I decided to fixate it to strictly cut out the top right. So again, I rotate the input until the scaffolding becomes the top right corner of the shape. Then I cut it with the laser cutter, and then I rotate it back. And again, I shifted the weight of the initial rotation from the physical layer to the wiring. So the shape signals are rotated before they go in. The scaffolding will always be the top right by default, and only after cutting, I rotate the actual shapes into the orientation they eventually need to have. And that, my friends, is the end of the line for today. This was a little introductory video to the topic of the floating piece factories. And in upcoming videos, we will have a closer look at what they look like, see them at work, look at how the wiring's been set up, all that good stuff. So, as always, I want to thank you for watching. I hope you had fun. Leave a like, leave a comment, always appreciate it. And then I will see you again next time. Take care. Bye-bye.